Hey everyone, in this video we're going to talk about something called the average rate of change. Just a very quick introduction. So average rate of change. Average rate of change. And we're going to come up with the formula. It's pretty easy to come up with, and then I'll do a simple example. So first we have a graph. Say there's the y-axis and that's the x-axis. Wow, it's a pretty straight line. Okay, and then say it looks like this. Okay, there's our graph, and this is the graph of y equals f of x. Okay, so every point on this graph is an ordered pair, x comma y. And we need 2 points. Say this is x1, and say this is x2. And then so here, this is the y value corresponding to x1. So that's going to be f of x sub 1. And this is x2. And this is the y value corresponding to x2, so that would be f of x sub 2. Okay, so if we draw a line connecting these 2 points, this line has a name, okay? It's called the secant line. Secant line. And so the average rate of change is just the slope of that line. So again, if you just draw any random graph, you connect the dots, take 2 dots, connect them, and you get a line. The average rate of change of the function from here to here is the slope of that line. So it's just a rate of change. And we measure it by just drawing a line between 2 points. So again, if I just do a random graph, pick 2 random points, connect the dots, that's called the secant line, and the slope of that line is called the average rate of change. That's all it is. So how do you come up with the formula? Well, you can find the slope of a line. So I'll draw a little triangle here. And slope is rise over run. All right, slope is rise over run. Terrible handwriting. So the rise here, well, this distance here is this one here. That's f of x sub 2. And this little baby distance here is f of x sub 1. So to get the distance we want, which is right here, this little yellow distance, that's the rise, we take the big distance and subtract the little distance. So the big distance is this one, so f of x sub 2, minus the little distance, so f of x sub 1. So you just subtract. So the big y value minus the little y value gives you the y value you want right there, that red marker. And then the run, well, that's pretty easy. This distance here is x sub 2. This distance here is x sub 1. So to get the distance you want, which would be, I guess, let me change colors, this green distance, you would do x2 minus x1, and that would give you this green distance here. So that's the run, x2 minus x1. So that's the formula for the average rate of change. Let's go ahead and do a really simple example so you see how it works. Say we have f of x equals, I don't know, x squared. And let's find the average rate of change from x1 equals 1 to x2 equals 3. So all you do is use the formula. So f of x2 minus f of x1 over x2 minus x1. Now, it doesn't matter which one is x1 and which one is x2. You get the same answer. What I always do is I don't even think about the formula. I just match them. So I'll put 3 here because I'm writing the formula down. And then this number has to be down here always. And then minus, minus, and then f of 1, and then this number has to be down here. So for example, you could have done it like this. F of 1 minus f of 3, and then you just do matching. So 1 is here, so it has to be below. Boom. 3 is here, so it has to be below. Boom. As long as these numbers match, you're okay. So if this number matches this number and this number matches this number, you'll always get it right. So f of 3, well, here's f of x. That means we replace all of the x's with 3's. So it would be 3 squared minus, and then f of 1 is 1 squared over 3 minus 1. So we get 9 minus 1 over 2. Oh, wow. 9 minus 1 is 8. How convenient. Over 2. And so we get an answer of 4. Hope that made sense.